This screencast is about significant figures, which are often referred to as Sig Figs. So, a significant figure is a measurement that consists of all the digits known with certainty, plus one final digit, which is often uncertain or is estimated. The term significant doesn't necessarily mean certainty, okay? So let's take a look at this ruler, which is measuring an ink pen. And as we look at this ruler, we can see that the ink pen definitely goes past the 4, but it's not quite to the 5. So we know we're at least 4 centimeters. And as we look a little closer, we notice that we are past the 0.7 mark, but not quite to the 0.8 mark. So we know our pen is at least 4.7 centimeters. But now we need to show where it lies between the 0.7 and the 0.8. So we would say our measurement is 4.72 or 4.73 centimeters. And those 3 digits would be significant. So how do you determine if a digit is significant? Well, ask yourself, is there a decimal? If the decimal point is present, you want to start counting the number from left, so from the Pacific side of the country, and move from left to right, and you want to count all numbers from the first non-zero number. If, however, the decimal point is absent, you want to come over here to the Atlantic side of the country where the decimal point is absent, so you will count the number from the right and then count all numbers from the first non-zero and count all the way across the country. So let's take a look at how this works. How many sig figs are in each of the following measurements? Well, 28.6, a decimal point is present, so we count from left to right, starting at the first number that's not 0, so that's the 2, and we count until we finish with the number. So we have the 2, the 8, and the 6. So this digit has 3 sig figs. What about 3,440? Well, again, the decimal point is present, so we count from the Pacific to the Atlantic, so from left to right. So we would count the 3, the 4, the 4, and the 0. That gives us 4 sig figs. Next is 910. Notice in this number there is no decimal point, so in this case we count from the Atlantic side to the Pacific side. We start counting at the first digit that's not a 0. So we start counting at the 1, and we continue counting until we get to the end of the number. So we count the 1 and the 9, giving us 2 sig figs. Next we have 0.04604. The decimal point is present, so we count from the Pacific side to the Atlantic side, starting at the first number that's not a 0, which is the 4, and counting to the end of the number, which gives us a total of 4 sig figs. For our final problem, we have 0.0067000. Again, the decimal point is present, so we count from the Pacific to the Atlantic side, starting at the first non-zero digit, which is the 6, and counting to the end of the number. So we count the 6, the 7, the 0, the 0, and the 0, giving us a total of 5 sig figs. So now how do we do math when it involves sig figs? Well, when you're adding or subtracting, the answer has to have the same number of digits to the right of the decimal point as there are in the measurement with the fewest digits to the right of the decimal point. For multiplication or division, the answer can have no more sig figs than are in the measurement with the fewest number of sig figs. So let's look at some examples. If we were taking 5.44 minus 2.613, the first thing I want to do is determine how many places after the decimal point are in each number. 5.44 has 2 digits after the decimal point, and 2.6103 has 4 digits beyond the decimal point. Next, I'm going to actually do the math. So I'm going to take 5.44 minus 2.6103, and I get 2.8297. Now this is my answer, but I want to round it so that it also has 2 places beyond the decimal point, because that's the smallest number of places after the decimal point for any of the numbers that I was given. So that means I want the 8 and the 2 to be significant, but I need to know where to round this to. So to figure that out, I look at the next number over, which is the 9. And since it's a 9, I'm going to round up. So my answer will be 2.83 meters. For 2.4 grams per milliliter times 15.82 grams per milliliter, I'm going to be solving in a similar way, except instead of counting decimal places, now I'm counting sig figs. So the first number here has 2 sig figs, and this number has 4 sig figs. Now I take my 2.4 times 15.82, and I get 37.968. I want this answer to have 2 sig figs, so the 3 and the 7 are going to be significant, but I need to figure out how to round by looking at my 9. The 9 tells me that I need to round up, so my answer will be 38 grams per milliliter. Now, how does this work with conversion factors? Well, in conversion factors, there's no uncertainty because most conversion factors are defined quantities. So we'll use this rule of thumb. Whatever number of sig figs you start with, you should be the same number you end with when you're converting. So we're not counting how many sig figs are in each conversion factor, but how many are in the quantity that we're given, and then our answer should have that same number of sig figs. Please write down any questions and ask Mrs. Benke in class. I know sig figs can be confusing, but we'll be doing a lot of practice, and if you have your questions written down and can ask them at the beginning of class, it will make this a lot easier.